All right, in a quadratic relationship, the name of the curve that is graphed has a specific name. It's called a parabola. Like a linear relationship is a straight line. There's not really a name for an exponential curve. I like to call it a skateboard ramp. But let's go ahead and draw it. And what it looks like if it's a positive relationship is kind of like a U. And if both sides of the graph go up, it's positive. If both sides, I'm going to delete this over here, but you could have it drawn like this, and this would be a negative parabola, okay? So a negative parabola, negative, both sides go down. And a positive parabola, both sides go up, like a smiley face. Up, okay? And now we're gonna start, let me change, maybe I can highlight this, labeling the different parts. So look at this part right here I'm gonna highlight. This part is the same on every graph. The place where it crosses the y-axis is called what? Y-intercept. It's the same for every type of graph we have except for an inverse variation, because an inverse variation does not cross either axis. Question? Right. Right. If it looks like a smiley face, you're in a positive mood. If it looks like a frowny face, you're in a negative mood. Good. So we have, that's the y-intercept. We also have a place where it crosses the x-intercept too. Let's change colors here. Let's make it green. What do you think we call it where it crosses the x-intercept? Or the x-axis? The x-intercept. So that's one. There's actually quite a few words for it. So x-intercept is one. You can write that down. I'll put it in green over here. Okay. So one is the x-intercept. And there could be two, right? There could be one, there could be 0, or there could be 2. Because you could have over here, you don't need to write this down, but I could have it here, it's not touching at all. Or you could have it to where it just touches. So you could have one x-intercept, no x-intercepts, or you could have 2 like ours over here has. Another name for this are the zeros, because y is 0 where it crosses. Another word for it is the solutions. What is the solution to a quadratic? Well, that's where it crosses the x-axis. And one more word for it is the root. And I'm giving you all of these different words because I'm not sure when a question is going to ask you, oh, is it asking you for the x-intercept? Is it asking you for the solution? Is it asking you for the zeros? Is it asking you for the root? It may use any one of those terms, okay? So we need to know all of them. Now, we also have a point here for a positive parabola. This is where the point, it starts going down, but then it turns and it goes up. If it were a negative parabola, I'm going to delete this. If it were a negative parabola, it would be where it starts going up at the point where it starts going down. And there's a name for this, and we call this, well, there's a couple different names. One name that works for both a positive and a negative is the vertex. Okay? If it's a positive parabola like the one I have drawn, that's the minimum point, right? Minimum. It's never going to get any lower than that. It's the smallest. If it were a negative parabola like this, instead of being a minimum point, it's a maximum point, okay? And I want to draw this over here because I don't want to put maximum here when this is obviously a minimum point, okay? And then we have one more part of this I want to draw. What color haven't I used? Orange? Okay. And that's this line that comes straight down. It's an imaginary line straight through the vertex. Okay. where if we folded it, okay, I know my picture's terrible, but it should be symmetrical. If we folded it along this line, it should line up, okay? And that's why this is called, where's my pen? That's not what it's called. Oh, there it is. Okay. Line of symmetry. Yeah. You guys dealt with symmetry in 7th grade, I think, yeah? Oh, good. I don't know what you guys do in elementary school, so yeah. Oh, cool. So, all right, so this is what the graph of a quadratic relationship. So next, let's look at what this looks like on a, what's next? Table, right? How can we tell if a table is a quadratic relationship, right? So we have an x value, and we also call the x value our input value. Just a little review here. And our y value is our output value. So if we're given an equation, right? If we're given an equation, we should be able to create a table from it. So take a look. I'm just playing around with the color now. If y is really equal to, if my output is really equal to x squared, that's a parabola. I can tell, in algebra 2, we call the exponent the degree of a function. So a quadratic has degree 2, okay? A quadratic, the highest degree is always going to be 2. Maybe we should throw that over here. The highest degree of a quadratic, and by degree we mean exponent, is 2. So remember how we could tell, I'm going to erase this over here, but I'm just going to write it down for you guys to, as I'm talking. Remember how we could tell in an exponential relationship, I can tell it's exponential because my exponent is a variable, okay? Well, I can tell that an equation is quadratic because my highest exponent is going to be 2. My highest degree is going to be 2, right? So just FYI. All right, so if I started here with -3, my input is -3. My output is x squared. What is -3 squared? What is -3 times -3? Because a negative times a negative is a positive, so we get +9 back, right? And then let's do -2. What's my output? +4. -1, my output is 0, my output is 1, my output is 2, my output is +4. 3, my output is +9. So do you guys see what happened? Do you guys see what happened? We started, I'm going to do a little sketch over here. A sketch means I'm not going to put all of my numbers on it. My highest one was 9 in this little table. So if I started at -3, I started at 9. What's my minimum point? 0, 0, right? And then over here at +3, it went back up to 9. So there's my parabola, right? So you can tell usually from, sorry, that's ugly. You can tell usually from a table because it'll either start high. Ooh, let's change the color. It'll start high, get smaller, and then start getting bigger again. And do you notice these numbers match up? 1 and 1 and 4 and 4 and 9 and 9. That's what makes it symmetrical, right? Okay. I felt like there's one other thing I wanted to tackle over here. Oh, when we have a linear equation, we're always adding the same number each time, right? So obviously that's not happening because we're subtracting 5, then we're subtracting 3, then 1, then adding. When we have an exponential relationship, we're multiplying by the same number each time. That's obviously not happening. For a table, what is happening is we're going to look at the second difference. So check this out. Between 9 and 4 is what? 5? Between 4 and 1 is? Between 1 and 0 is? Between 0 and 1 is? Okay, now check this. This is called the second difference. Between 5 and 3 is? Between 3 and 1 is? Between 1 and... Between 1 and... This should be... because we're going from... There's still 2. Do you see what I'm saying? We're going up 2. We're going to 0 and then we're going back to 1. And then from 1 to... Well, we don't have the second difference here. Because between 0 and 1 is 1. Between 1 and 4 is 3. Between 4 and 5 is 4 and 9 is 5, right? So between 1 and, that was the first difference that we didn't do. Between 1 and 3 is 2. Between 3 and 5 is 2. So in a quadratic, the second difference is always the same. Second difference. So a couple different things, difference is always the same. Okay? So we have, what does it look like in a graph? What does it look like in a table? What's last? What does it look like in an equation? Okay, we have 3 types. 1, just like we had 3 types, just like we had 3 types in a linear relationship, we have 3 types in a quadratic relationship. Linear relationship, we had slope-intercept form, point-slope form, and standard form. For exponentials, we had a growth and we had a decay. For quadratics, we have the first one is we have a standard form again, but this time we can also call it, sometimes we call it a general form. So again, you have to know both of these words, general form. This is the form you use with the quadratic function, quadratic equation. And we'll learn that later, but I'm just going to put it here now. Equation. Tell me if I spell anything wrong. And standard form is ax squared plus bx plus c equals 0. Remember, our zeros are our solutions. That's why it has to be equal to 0. C is also going to be your y-intercept. Okay. All right. The second one, I didn't turn it back into a pen. And I think I run out of time after 15 minutes because I'm on the free version. So let's see how far we can get. We'll have to make 2 different videos. The second one is factored form. Wait, I'm going to pause this so I don't run out of time to write them down for you. Okay, and I paused that, and now there's a lot more writing on there. So write this down, and then we'll start our next video where I will explain it. So you might need to pause this.